Let's take a look. 1.1.1. We have x squared minus 3x plus 2 being equals to 0. We are supposed to solve for x. It should be easy to see that we can simply factorize here. We are looking for two factors of 2, of which when we multiply we get 2, obviously, because they are factors of 2. But when we add, we get minus 3. That is minus 2 and minus 1. Okay, if you multiply those two numbers, you get plus 2. But when you add them, you get minus 3. So x is equals to 2 or x is equals to 1. That is the solution to 1.1.1. Let's take a look at 1.1.2. So 1.1.2, we have 3x squared being equals to minus 2 minus 6x. We're supposed to round off our answer to 2 decimal places. Obviously, we are going to use the quadratic equation here, the quadratic formula. But we still need to take minus 2 and minus 6x to the left-hand side, of which we're going to get 3x squared plus 6x plus 2 being equals to 0. Should be easy to see that A is 3, B is 6, and C is 2. So we're going to have x being equals to minus b, so that is minus 6, plus or minus the square root of b squared minus 4ac. So b squared, we have 6 squared minus 4ac. A is 3, c is 2. There we go. And then we divide everything by 2a. A is 3, so we are dividing by 2 multiplied by 3. X is equals to. So let me just go ahead and put that in my calculator. Minus 6 plus the square root of 36 minus 4 multiplied by 3 multiplied by 2 divided by 2 multiplied by 3. Okay, when one possible value of x is minus 0.42 when I round off to 2 decimal places, and the other value of x is, so let me replace the plus with the minus sign. I'm getting minus 1.58. Right, so there we go. That is our solution to 1.1.2. So obviously, with the quadratic formula, it's very easy to make a mistake in substitution or make a mistake in determining the value of a, b, and c. So let's verify and just check and see if everything is fine. So 3x squared, we take minus 6x to the left hand side, it becomes plus 6x and then plus 2. That is perfectly fine. A is 3, b is 6, and c is 2. No wrongdoing there. And then we have minus b, so that will be minus 6. And then b squared is 6 squared minus 4ac. A is 3, c is 2 divided by 2a. And then let me just put it in the calculator again one more time. We want to make sure that we don't make any mistake here. Okay, I'm still getting the same answers. I'm still getting minus 0.42 and minus 1.58. But I can always substitute them back into this equation and see if I'm going to get 0. So 3 multiplied by minus 0.42 squared plus 6 multiplied by minus 0.42 plus 2. Does that give me 0? That gives me 0.0092. So obviously, because I have rounded off, it's not going to give me exactly 0. But I'm quite happy with that answer. Okay, let me move to the following one. When I move to the following one, I have to substitute minus 1.58. So minus 1.58 and minus 1.58. What do I get? I get the same thing, minus, not minus, but 0.0092. So I'm quite happy with my answers. I can do 1.1.3. So let's go ahead and do that. 1.1.3, we have 2x minus 1 being equals to the square root of 1 minus x. We have to admit this is actually an easy case. A difficult case is if you have a plus 3 or any other constant on the same side with a square root. That becomes, well, in this side it will be fine, but imagine you have a square root here and you have plus 3 there. what do you do in this case? You still need to square on both sides, but issues are going to arise. But in this case, we can fairly say that this answer is, well, not this answer, but this question is not too difficult. In squaring both sides, we are going to get 2x minus 1 squared being equals to the square root of 1 minus x squared. I copied that down again and squared it just for the faint-hearted ones. But let's square it. 2x multiplied by 2x is 4x squared. And then 2x multiplied by minus 1 is minus 2x. You multiply that by 2, you get minus 4x plus 1. Plus 1 is coming from minus 1 multiplied by minus 1. So there we go. And then on the right hand side, we're going to have 1 minus x. Okay, so 4x squared. So we have minus 4x plus x. So that is minus 3x. And then 1, when we take this one to the left hand side, we're going to get 0. So we have 4x squared minus 3x being equals to 0. Okay, I'm happy that we are kicking 0 there, because it sort of simplifies our problem. Our problems no longer that difficult anymore. We can take a common factor of x, of which when we do that, we're going to get 4x minus 3 being equals to 0. So we have two numbers multiplying each other, and then the product is 0. So one between the two numbers has to be 0. So what are we saying? We are saying that x is equals to 0, or 4x minus 3 is equals to 0. In order for 4x minus 3 to be equals to 0, we need 4x to be equals to 3, and therefore x is equals to 3 over 4. So these are our two possible solutions. X is equals to 0 or x is equals to 3 over 4. But take a look at this. We got this answer after we squared both sides. But this problem that we are solving is this one. This is the problem that we are solving. But we got our answer after squaring both sides. So it is very possible that one between 0 and 3 over 4 might not necessarily be a solution to our answer. Let's find out which one. When we substitute 0 on the left hand side, we're going to get minus 1, right? And on the right hand side, we're going to get square root of 1, which will just give us 1. Is minus 1 equals to 1? Well, that should be an easy question. They're not equals to each other. So this is not true. So x is equals to 0 is not a solution to this problem. Because clearly, when we substitute 0, we don't get the same answer on the left-hand side and on the right-hand side. Okay, let's check 3 over 4. So 2 multiplied by 3 over 4 minus 1. Where is my calculator? So let me go ahead and do that. 2 multiplied by 3 over 4 minus 1. I'm getting 1 over 2. And then let me not use equals to there because I'm not sure they're equal to each other. And then the square root of 1 minus 3 over 4. Is it just 1 minus x? Yeah, it is. So 1 minus 3 over 4, we are getting 1 over 2. So they are equals to each other when x is equals to 3 over 4. So x is equals to 3 over 4 is actually our correct solution. X is equals to 0 is not a solution because minus 1 is not equals to 1. There we go. That is 1.1.3. 1.1.4. I feel like I'm going so fast in this video. It's like I'm doing, it's like I'm playing on 1.5x. No pun intended. But anyway, stories. X plus 3 multiplied by 3 minus x being less than 0. Some people, for some reason that I don't know, will multiply out in this situation and just make a mess of everything. But we're not going to do that, obviously. We are going to say critical values. So always say critical values before you change the inequality to an equal sign. Because if you just change the inequality to an equal sign, what is it that you're doing? You're just changing things without giving reason. But if you say critical values first, I can see what is going on. So x plus 3 multiplied by 3 minus x is equals to 0. So x is equals to minus 3 or x is equals to 3. So these are our critical values. We need to then write our answer, right? Our final answer in terms of an inequality. So this is what I always do. I say that there's two possible solutions after you get your critical values. Your answer lies between the critical values or outside the critical values. If it lies between the critical values, what will your solution look like? Well, x will be between -3 and 3. And then if it is outside the critical values, x will be greater than 3 or x will be less than -3. These are our possible solutions. We can easily do that by taking a number between -3 and +3. A simple number to work with is 0. So let's take 0 and substitute it in our inequality and see if it's gonna be satisfied. So in substituting 0, we get 3 multiplied by 3 being less than 0. 3 multiplied by 3 being less than 0, does that sound fine? No, it doesn't sound fine. 9 is not less than 0. So we know that this is not a solution. So we can cancel it out. That is 1.1.4. Let's take a look at 1.2 and see what is happening here. So solve for x and y simultaneously. The first equation, 2x is equals to y plus 2. And then the second equation, I'll tell you why I'm laughing. The second equation, y minus 2 is equals to x squared minus 3x. There's somebody where in this equation, they came and they said x is equals to y plus 2 and they divide by 2 on both sides. Okay, that is totally fine. Mathematically correct. But it's not a good strategy because you are unnecessarily complicating your life. Because now you have to deal with a fraction. You have to substitute that fraction in place of x and square it, which is a very difficult process. Why don't you just make y the subject of the formula instead and take 2 to the other side and have 2x minus 2. And then you can substitute these here, of which let's go ahead and do. 2x minus 2 is equals to x squared minus 3x. Not too bad. We're not squaring a fraction. 2x minus 4 is equals to x squared minus 3x. So we're going to have x squared minus 5x plus 4 is equals to 0. Should be easy to factorize this. X minus 4, x minus 1 is equals to 0. X is equals to 4 or x is equals to 1. If x is equals to 4, y will be equals to 2 multiplied by 4 minus 2. So 2, 4, 8 minus 2, 6. And then y, well, when x is equals to 1, y will be 2 multiplied by 1 minus 2. That looks like y should be equals to 0. Right, so there we go. That is 1.2. Let's take a look at 1.3. Okay, 1.3, what is happening? Let's take a look. An athlete calculated that if he increases his current speed of x kilometers by 5 kilometers per hour, he can reduce his time by 12 minutes. He will be participating in the city marathon, which is 72 kilometers long. Determine the value of x. Okay, so we have some words. We have some words here. And for some way, somehow, we need to put this into equations and solve the problem. 1.3, the last question, equation 1, it's always a bit challenging, right? But let's take a look and see what is happening. So his speed initially is x, right? I think this question, if you're doing mathematics and history, you probably get it wrong. What is the probability that you're going to get this question right if you're doing mathematics and history? Well, maybe 1-2 people will actually get it right who are doing history. But if I had to place a bet, people that are doing history will get this question wrong. So the speed initially is x. And then when we increase the speed, let's say speed with that note there on top, we increase it to x plus 5 kilometers per hour. Okay, and then the time, we reduce the time by 12 minutes. when we increase it to x plus 5. Okay, so what is the time initially? What is the time initially when the speed is x? What is the time when the speed is x? And what is the time when we increase the speed to x plus 5? Okay, let's think about that. Let me just drag this down. So the time, well, we know that distance is equals to speed multiplied by time. So time is equals to distance divided by speed. So the time when the speed is x is the distance, which is 72, right, divided by x. Okay, and then when the speed is x plus 5, the time will be 72, the distance, divided by the speed, which is x plus 5. So let's also differentiate this time because they're not going to be equal to each other. But we know that we reduce the time by 12 minutes when we increase the speed to x plus 5. So t minus t prime should give us 12 minutes. T minus t prime should give us 12 minutes. But our speed is in kilometer. Well, not our speed. Our distance is in kilometers and our speed is in kilometers per hour. So we need to convert that 12 minutes to hours. So 12 minutes to hours. So 12 minutes divided by 60. We convert it into hours, all right? So 12 over 60, that is 0.2. So we decrease the time taken by 0.2 hours when we increase the speed by 5 kilometers per hour. So t, the initial time when the speed is x, minus t prime when we increase the speed by 5 kilometers per hour should give us 0.2 hours. Okay, because we reduce the time by that much. So what is t? 0.2. Okay, I'm trying to write here, facing an issue. 0.2. Okay, so t is okay. I don't know what's happening, but for some reason I can't write anymore. I'm trying to scroll, but I can't. On this side I can scroll, but on this side I can't scroll anymore. Okay. Okay, I think it's fine now. So t 72 over x, t prime 72 divided by x plus 5 is equals to 0.2. Okay, so when we have this equation, it's just a matter of solving for x, right? And in doing that, you will end up with x being equals to 40. Right. How you actually get from here until x is equals to 40 is really up to you how you choose to manipulate it. But you have to end up here one way or another. There we go. The fourth term of an arithmetic sequence is 5 and the 14th term is 15. Quite a basic question, right? We expect this kind of questions and series and sequence. And the first question, 2.1.1, calculate their common difference. So let's take a look at what we are given and make sense of it. It is said that T4 is equals to 5, but we know fully well that T4 is just A plus 3D. So A plus 3D is equals to 5. Okay, and then on the other hand, T14 is said to be equals to 15. So we have A plus 13D being equals to 15. Right, we want the common difference. So what can we do? We make A the subject of the formula in this equation and make A the subject of the formula in this equation and equate the two. In doing that, we're going to get A being equals to 5 minus 3D. And then on the other equation, A is equals to 15 minus 13D. So we can equate these two because they are both equal to A. So 5 minus 3D is equals to 15 minus 13D. Let's take minus 13D to the left hand side. We're going to get plus 10D. Minus 3 plus 13. This is equals to 15 minus 5, which is 10. It should be easy to see that D is equals to 1. There we go, 2.1.1. Let's take a look at 2.1.2. Determine the general term of the sequence. So Tn is equals to A plus n minus 1 multiplied by D. We have A and D as variables that we need to figure out. We know fully well that d is equals to 1. But what is a equals to? We just need to substitute d into either this equation or this one here. So let's go ahead and substitute it on the first one. We're going to have 5 minus 3 multiplied by 1, which is equals to 2. So in substituting that back into Tn, we would get 2 plus n minus 1 multiplied by the difference, which is 1. So 2 plus n minus 1. So this is equals to n plus 1. 2 minus 1 is 1. So there we go. 2.1.2, we have Tn. 2.1.3, calculate the sum of the first 22 terms. So S22, well, let's start by saying Sn. Sn is equals to n over 2 multiplied by 2a plus n minus 1 multiplied by d. Well, I've memorized this formula, but it is on the formula sheet. You don't have to really memorize it. So S22 will be equals to the value of n. We're looking for the sum of the first 22 terms. So we're going to have 22 over 2 multiplied by 2. A is 2 also, plus n minus 1. N is 22, so we have 22 minus 1 multiplied by d. So without trying to act fancy, let me just substitute that in my calculator. So I have 22 divided by 2 multiplied by 2a, so that will be 4 plus 22 minus 1 multiplied by 1. I'm getting 275. Okay, so there we go. The sum of the first 22 terms is 275. To the people who actually wrote this question paper, if you got anything wrong in question 2, there's still a lot of work that you need to do. This question is as basic as they can be. I'm sure if you have been solving previous questions, you should have came across this kind of question at least 10 times. It's very, very basic. It does not require you to do anything rigorous. You just dig into the basics. But anyway, stories. 2.2, let's take a look. A quadratic pattern has the following properties. T1 is equals to x, so I'm going to put that there. T2 is 7. T4 is 7x. Okay, so I have T4, which is 7x. Let's worry about T3. T3 minus T2 is equals to 6. So so T3 minus 7 gives us 6. So T3 should be 7 plus 6, which is 30. So this is what we have. The question says, let's find the value of x. 4 marks. So let's see how complicated it will get. Well, we know that the difference here will be 7 minus x. The difference here obviously is 6. And here we have 7x minus 13. Okay, so these differences, they form an arithmetic pattern. So if we say this T2 minus this T1 is equals to this T3 minus T2, we shall get the value of x, right? Because those form a arithmetic sequence and we have a common difference. But let's see. What is 6 minus, so we have, let me write it somewhere else. So we have 6 minus 7 minus x. I'm writing it like this because I don't want to make a mistake. A lot of people will make a mistake here because of this minus sign that is outside, and this minus sign that is inside. So you have to be very careful when you have a situation like that. 6 minus 7 is minus 1, and then minus multiplied by minus will give us positive. So we have x minus 1, which is here. And then now we're going to have 7x minus 13 minus 6. This will give us 7x minus 19. So here we have 7x minus 19. And these two are equals to each other. They're equals to each other because that's the second common difference of a quadratic, or the difference of the arithmetic, which is formed by these terms, however you look at it. But ultimately, we're going to have x minus 1 being equals to 7x minus 19. This is minus 19 and not minus 9. Minus 19. So take 7x to the left hand side, we get x minus 7x. So this is minus 6x. And then we get minus 19 plus 1, which is minus 18. Should be easy to see that x is equals to 3. Here we go. determine the sum to infinity, that is 3.1. So we know fully well that the sum to infinity is given by a divided by 1 minus r, where a is the first term. In our series, a is 2. That is easy to see. So a is 2. But what is r equals to? R is equals to the ratio of any two consecutive terms. So we can say r is t2 divided by t1, or we can say that it is t3 divided by t2, any two terms that are next to each other. Well, we can also find r using t3 and t2. Well, t3 and t1, but in this case, that won't be necessary. t2 is 2 over 3, as we can clearly see, right? And t1 is 2. So this is equals to 2 over 3 multiplied by 1 over 2. So this is just equals to 1 over 3. So here we go. We have a, we have r. We can go ahead and then say that the sum to infinity, well, it is equals to a, which happens to be 2, divided by 1 minus r. R is equals to 1 over 3. So we have 2 divided by 2 over 3. So this will be equals to 2 multiplied by 3 over 2. 2 and 2 cancels out. The sum to infinity is 3. That is 3.1. We have the value of a is given to us. We just had to determine r and substitute in the formula and get the sum to infinity, which is equals to 3. What about 3.2? Show that the sum of the first n terms of the series is given by this expression. Well, we will see how we can get there. Let's start with the basics. Sn is equals to a multiplied by 1 minus r to the power n divided by 1 minus r. Okay, r is less than 1. So we are interested in the sum of n terms. Okay, so not the sum of any specific number of n, but just the general formula for the sum of n terms. So a, we already know that a is 2. 1 minus r is 1 over 3, like we determined. So we have 1 over 3 to the power n. Everything divided by 1 minus r. So that is 1 minus 1 over 3. So we will get 2 multiplied by 1 minus 1 over 3 to the power n divided by 2 over 3. Okay, we're making progress. So let's multiply out by 2 on the numerator. We'll get 2 minus 2 over 3. Oh, wait a minute. That is incorrect. When you multiply 2 by 1 over 3 to the power n, the 2 just becomes a coefficient of 1 over 3 to the power n. We don't say 2 over 3. So this is going to be 2 minus 2 multiplied by 1 over 3 to the power n. Okay, divided by 2 over 3. Instead of dividing by 2 over 3, we can write it as multiplied by 3 over 2. I think that is how we get to what we are supposed to get ultimately. Okay, so this is going to be equals to 2 multiplied by 3 over 2. We are multiplying out by 3 over 2 now. Minus 3 over 2 multiplied by 2 multiplied by 1 over 3 to the power n. So take a look at this. 2 and 2 cancels out. We are left with 3. 2 and 2 cancels out. We are also left with 3. So minus 3 multiplied by 1 over 3 to the power n. Well, this is just 3 minus 3, 1 over 3, everything to the power n. There we go. We have showed that the sum of the first n terms of the series is given by that expression. Not too difficult. Well, I would expect most people to at least get to this point. Okay, and what you do from there on is really up to you. I think there might be a couple of different ways you can actually progress from there, but that is besides the point. Let's take a look at 3.3. So 3.3, calculate the smallest value of n for which the sum of the first n terms is greater than 2.99. So we need Sn to be greater than 2.99, but Sn is 3 minus 3, 1 over 3 to the power n. We need that to be greater than 2.99. So the first step, the first organic step is to take 3 to the right hand side. So we're going to have minus 3, 1 over 3, everything to the power n, being greater than 2.99 minus 3. So let me put that in my calculator. 2.99 minus 3, that is, well, load shedding, so I can't really see, minus 0.01, minus 0.01, so greater than minus 0.01, so minus 3 multiplied by 1 over 3 to the power n. Okay, so let's divide both sides by minus 3. So we're going to get 1 over 3 to the power n. Well, the inequality sign changes when we divide by a minus sign, okay? Because if 4 is greater than 2, when you divide both sides by minus 1, minus 4 is no longer greater than minus 2, right? So every time you divide by a negative 1, the inequality changes where it is pointing. So because we are divided by minus 3 there, it is going to change and be what we are saying it is there. Okay, and then minus 0.01 divided by minus 3. That is 1 over 300. So we have 1 over 300. Okay, let's take a look. How can we progress from there on? Well, we can introduce the log on both sides because n is there at the top. So n log of 1 over 3 is less than log of 1 over 300. Okay, let's progress. So dividing both sides by log 1 over 3, n should be less than log of 1 over 300 divided by log of 1 over 3. So n is less than. Okay, so let's take a look. Log of 1 over 300 divided by log of 1 over 3. Let's see. I'm getting 5.1918. Okay, so the question says calculate the smallest value of n for which the sum of the first n terms is greater than 2.99. I'm getting n less than 5.1918. That is a bit weird. Should I have said critical values and change the equal sign to equals to and then figure it out manually? Okay, let me just say that n, well, let me say critical value n is equals to 5.1918. Okay, now I will figure out whether I want my n to be greater than 5 or my n to be less than 5. Well, my n to be 5 going down or my n to be 5 going up. Let's see about that. Okay, so when n is equals to 5, so let's say S5, what do we end up with? 3 minus 3, 1 over 3 to the power 5. Let's try 5. Okay, so I'm going to have 3 minus 3 multiplied by 1 over 3 to the power 5. When I substitute 5, I get 2.98. Okay, let me try substituting 4. Okay, when I substitute 4, I get 2.96, as you would expect, right? If the sum of the 5 terms is 2.98, then you would expect the sum of the 4 terms to be less than that, given that they are both positive. They are all positive, those terms. Okay, let's try s being equals to 6. I just want to check here. S being equals to 6. Replace 4 with 6. Let me do that. I'm getting 2.995, of which 2.995 is clearly greater than 2.99, right? 2.995 is clearly greater than 2.99. So the question is saying, calculate the smallest value of n for which the sum of the first n terms is greater than 2.99. So the smallest value of n is 6, right? I think these will be a bit confusing because you end up with having n being less than 5.1918. I think some people would be tempted to say n is equals to 5, but clearly n is equals to 5 does not work for us here. What works for us is n being equals to 6 as the smallest value of n. Right, so moving forward, if I'm coming across a question like this, instead of using the inequality, I will quickly change it to an equal sign and justify by saying that I'm looking for a critical value. But anyway, stories 3.3 and is equals to 6. Here we go. So the figure below shows the graph of h of x, which is said to be equals to log of x base a. Point A lies on the curve and B is the x-intercept of h. The first question, 5.1, we are supposed to calculate the value of a. So what do we have? H of x is equals to log of x base a. We have three variables here, three unknown variables. H of x, which is y, x, and a. So what can we do? We want a. How can we find x and y in order to be able to find a? We can substitute any point which is on the function. We don't know the coordinates of b, we only know the coordinates of a. So we are going to substitute the coordinates of a so that we can have a corresponding x and y, and then sub it into h of x. Okay, let's do that. Y is 4. Log of the base is a, x is 16. So in applying log laws, we get a is equals to 4, b equals to 16. So it will be advantageous for us to write 16 with the numerator of 4, because in doing that we can drop the exponents and equate the bases. How can we possibly do that? A to the power 4 is equals to 2 to the power 4. 2 by 2 is 4, 2 by 2 is 4, and 4 by 4 it's 16. So that is okay. No wrongdoing there. So when we drop the exponents, we end up with a being equals to 2. So there we go. That is our answer. But now we know that h of x is equals to log of x base 2. Well, we don't have to write these. We can just end here. But I think we gonna need to use it as we move forward. Okay, let's take a look at 5.2. So 5.2, write down the coordinates of b. Okay, we now know that h of x is log of x base 2 as I've stated. Now we need the coordinates of b. B is the x-intercept. What do we know about the x-intercept? Y is equals to 0. So the coordinates of b, we have x and 0. Let's substitute that into the equation and find x. Y is 0. Log of x base 2. Again, applying this log law. 2 to the power 0 is equals to x. 1 is equals to x. So the coordinates of b, we have 1 as the x value and 0 as the y value. Quite straightforward. If you've been, solving any past exam questions, it should be easy to see that the coordinates of b are 1 and 0. It should be easy to see that we need to substitute b into h of x. Quite a basic equation. It doesn't require us to do anything cutting edge. 5.3, we're looking for h inverse. So h of x is equals to log of x base 2. The first step in finding the inverse, we need to swap x and y. Let's do that. So in place of h of x, we put x. And then in place of y, we put x. And then the second step, we make, in place of x, we put y, not x again. And then the second step, we make y the subject of the formula. So how do we do that? Again, the log law. It's very crucial to know these log laws. And then we end up with 2 to the power x being equals to y. So, well, let's just write it nicely. y is equals to 2 to the power x. 5.4, write down the range of H inverse. Okay, so H inverse is equals to, okay, the question in 5.3 said that we must write it in the form H inverse of x. So H inverse of x is equals to 2x. Okay, I almost forgot that. Well, not really forget, I didn't see it, I just solved the question. H inverse is equals to 2 to the x, obviously, and we're supposed to determine the range. So because we have a base which is 2, right, it implies that no matter what you substitute in the place of x, you are never going to get a negative value, and you're also never going to get 0. There's nothing you can substitute here in place of x that will give you 0. Well, if you substitute, let's say, minus 1 billion, right, your calculator will give you 0. But the answer is really not 0. The answer is just 0 point, a lot of zeros. The calculator just decides to give you 0, right? So what am I saying? I'm saying that the range here, y, is greater than 0. H inverse cannot be 0. H inverse cannot be negative. Y is greater than 0 all the time for H inverse. Here we go. Calculate the effective interest rate, that is 6.1. But the problem with this equation, let's take a look at the statement so that I can show you something. So we have T and M that invest their inheritance of 200,000, right, at 11.5% per annum compounded quarterly. After 10 years, they use their return on their investment to build a house at a cost of 1,850,000. They borrow the balance needed to build the house from a bank. Okay, the bank grants them a loan at an interest rate of 12% per annum, compounded monthly. They must repay the loan back over a period of 25 years. And then 6.1 again, calculate the effective interest rate. Do you see the issue with this question? It doesn't really specify which effective interest rate. Is it for the saving or is it for the loan? Well, we're not really sure there. But let's just calculate the one for the saving, okay, and see what we get. The steps that we're going to follow here are the same steps we would follow if we are calculating the one for the loan. So for the saving, 1 plus the effective interest should be equals to 1 plus the interest divided by, whether it is compounded quarterly or monthly, everything to the power m. Okay, so let me show you how that plays out. We are looking for the effective. So here we just have 1 plus the effective interest rate being equals to 1 plus. What is the interest? The interest given is 11.5. So that will give us 0.115 divided by m. Let me show you how m comes about, or how we determine m. M, it says that it is compounded quarterly. How many quarters do we have in a year? We have 4. So we would divide by 4 and then to the power 4. Okay, and then we go on to say before the effective interest. So our effective interest in this case will be equals to 12%. It will be equals to 0.12. So if we were to calculate the one for the loan, we would follow the same steps. We would have 1 plus the effective interest being equals to 1 plus the interest divided by m to the power m. But there's a slight difference here. Well, a major, not slight, right? 1 plus the interest for the loan is 12%. So we have 12%. We can write it as 12% or as 0.12. But then now it is compounded monthly. So the m would change. In this case, it will be 12 because we have 12 months in a year. And then we go on to also calculate the effective interest. So this question doesn't really specify what you're supposed to calculate the effective interest for. The best thing to do would be to just calculate it for both the compound, which is quarterly, and that which is monthly for the loan and the investment. But anyway, stories. There we go. We have our answer to 6.1. Let's go ahead and do 6.2. So calculate the value of the investment after 10 years. Well, they just deposit 200,000, right? And then chill out for 10 years. So not deposits every month or every quarter. It's just basic compound interest. So we have A being equals to P, 1 plus the effective interest to the power n. So A is equals to the principal amount, the amount which they invest, 200,000, multiplied by 1 plus the interest. The interest is 11.5 compounded quarterly. So we can write these as 11.5%. When you're substituting in your calculator, you can actually put this sign there, percent, right? It is there. So there's no issue in doing that. 11.5% divided by how often is it compounded? It's compounded quarterly. So we are going to divide that by 4. And then to the power n. And the number of years is 10, but it is compounded quarterly. So I'm also going to multiply that by 4. So A is equals to, so I have 200,000, 1 plus 11.5% divided by 4, everything to the power 40. So let's see, that is, I used 20,000 instead of 200,000. I was surprised. Yeah, that is 621,475.37 cents. There we go. So that is 6.82. That is the money that these two are gonna have after they save or they deposit 200,000 into the saving account for 10 years. And then 6.3 determine the loan amount needed to finish building the house. We know that the house costs 1.85 million, right? They only have 621,000 point something. So how much money are they actually gonna need to finance, right, in order to build the house? So the loan amount will be equals to the price of the house, essentially, or how much it's gonna cost to build the house, minus the value of their savings. This makes sense, right? Yeah, you want a house for 1 million, you have 500,000 in your savings. So where do you get the other 500,000? You get it from the bank. You take a loan. So the price of the house is 1,850,000 minus the savings. The savings. So let me do it like this: minus 621,475.37. This is equals to. So let me plug that in my calculator. 1,850,000 minus 621,475.37 cents. 621. I'm getting 1 million. So this is 1,228,524.63 cents. So there we go. This is the amount that these two will finance. That is the loan amount needed to finish building the house. That is 6.3. Let's take a look at 6.4. Calculate the monthly payment of the loan. Calculate the monthly payment of the loan. So we have the loan amount. Which is our P, right? Because we know that P is equals to X multiplied by 1 minus 1 plus the interest minus N, everything divided by the interest. So divided by I. Okay. So we're going to have P, the loan amount, 1,228,524. Let me check my calculator. 0.63 being equals to X. X is the monthly payments that we are going to make, right? It's what we're interested in. Multiplied by 1 minus 1 plus the interest. Okay. So the interest is 12%. So we're going to have 12% compounded monthly. So we divided that by 12. Everything to the power minus 12 multiplied by. How long are we going to take to pay off the loan? Over a period of 25 years. So that is minus 12 multiplied by 25. Okay, I close that bracket and I divide everything with the interest. So 12% divided by 12. Okay, so let me show you. X will be equals to this right here. Let me duplicate it. Okay, this divided by the coefficient of x. The coefficient of x is this entire thing. Coefficient of x is this entire thing. So let me duplicate it instead of dragging it from there. There we go. I'm getting 12,939. So x is 12,939.12 cents. So there we go. That is the monthly payment on the loan. 6.4. Let's take a look at 6.5. 6.5, calculate the balance of the loan after 15 years. Okay, so the balance of the loan after 15 years. Let me show you how we do that. So we've already seen that P is equals to X multiplied by 1 minus 1 plus the interest to the minus n, everything divided by the interest. We know what the monthly payment is. We know what the interest is. We need to figure out n. So we want to calculate the balance of the loan after 15 years. So 0, 10, 20, 25. So 15 years is somewhere here. So after we've paid the loan for 15 years, how many years are we left with? We are left with 10 years that we still need to pay. So that is the value of n we would use in this case. We are left with 10 years that we still need to pay. So in place of n, we just substitute with 10, right? That will be 10 multiplied by 12 because it is compounded monthly. Okay, so that is how you find the balance. You, in place of n, you substitute the amount or the number of months that are left that we still need to pay. Okay, so P will be equals to X, 12,939.12 multiplied by, I think everything will fit, it's fine, I can just write it here. 1 minus 1 plus 12% divided by 12 compounded monthly to the power minus 10 multiplied by 12. Everything, well, not everything, well, it can be everything because multiplication is cumulative, doesn't care about order. The interest 12% divided by 12. So I just needed to put that in my calculator and I'm getting 901,863.28 cents. So this is the balance on the loan after 15 years. Still a lot considering the fact that the loan was just 1.2 million. But that's what interest will do to you. 6.5, 6.6, determine how much interest they will pay on the loan in the 25 years time. So the interest paid on the loan in the 25 years time is a matter of saying the total payments, right? Minus the loan amount. So the total payment is 12,000, whatever. Yeah, that monthly payment is multiplied by 25 multiplied by 12, right? And then minus the loan amount, and you should get your total interest. Determine f prime of x from first principle if it is given that f of x is equals to 3x squared. So f prime of x is equals to the limit as h tends to 0 of f of x plus h minus f of x, everything divided by h, using first principles. So it's quite easy, it's quite straightforward. Here we just substitute in x plus h in place of x, and here we're just minusing with f of x, nothing complicated, and we are dividing by h. So let's work out the numerator first. In the numerator we have f of x plus h. So let's see what happens when we do that. F of x is 3x squared. So we're going to have 3x plus h, everything squared. So this is 3x squared plus 2xh plus h squared, right? And this will give us 3x squared plus 6xh plus 3h squared. That is f of x plus h. So what about f of x plus h minus f of x? Let's go ahead and do that. So that will give us 3x squared plus 6xh plus 3h squared minus 3x squared. So minus, well, not minus, but 3x squared minus 3x squared will give us 0. We're going to be left with 6xh plus 3h squared. We can then substitute these back into the equation. We're going to get f prime of x as the limit tends to 0, as h tends to 0, being 6xh plus 3h squared. We have solved that, right? F of x plus h minus f of x, everything divided by h. What we want to do at this point is to take h as a common factor on the numerator, of which when we do that we get h, and then 6x plus 3h, everything divided by h. Let's let h and h cancels out and let h tends to 0. So what is 3 multiplied by 0? Well, this is equals to 0. So f prime of x is equals to 6x. There we go. This is the same answer we would get if we are using the power rule. We would get 6x. 3 multiplied by 2, and then you subtract 1 from 2. So we are quite confident what we did is correct. That is 7.1. 7.2.1, determine f prime of x if f of x is equals to this entire thing. Okay, maybe there's a fancy way of solving this problem, right? But it is not immediately obvious to me. So how am I going to do the problem? I'm just going to do it the hard way. If that's even if there's a simpler way. But let's go ahead and do it. F of x is equals to x minus 1 multiplied by x to the power 6 plus x to the power 5 plus x to the power 4 plus x to the power 3 plus x to the power 2 plus x plus 1. I honestly feel like there is something that I'm missing here. There's a trick that I cannot immediately see. Well, okay. No, I just realized something. Okay, when we multiply out everything by x, right, we're going to get x to the power 7, x to the power 6, and then here we're going to get x squared, and here we're going to get x. And then when we come around and then subtract, multiply everything by minus 1, then x to the power 6 will get subtracted by x to the power 6, so on and so on. Let me show you what I'm saying. Okay, when we multiply out by x, we get x to the power 7 plus x to the power 6 plus x to the power 5 plus x to the power 4 plus x to the power 3 plus x to the power 2 plus x. We're multiplying out by x. When we have the same base, we add the exponents. Minus, now we are multiplying out by, when we multiply out by minus 1, we are going to get minus x to the power 6 minus x to the power 5 minus x to the power 4 minus x to the power 3 minus x to the power 2 minus x minus 1. So we get everything, but now it is just saying minus. So take a look at this. X to the power 5 minus, what am I doing? X to the power 6 minus x to the power 6, x to the power 5, in that way. Take a look at that. And then ultimately, we end up with x to the power 7 minus 1, of which when we derivate, we're going to get So this is f of, well, not f prime because we have not yet derivated there or attempting to. This is f of x, this is f of x, and then here we now have f prime of x because now I actually want to derivate, of which when I do that I'm going to get 7x to the power 6 minus 0, so we can just drop that. Okay, there we go. That is 7.2.1. 7.2.2, we're looking for dx of x to the 3 plus 2x squared plus x divided by x plus 1. In these cases, something in the numerator is supposed to cancel out with something in the denominator. Okay, so what approach can we take? We still keep this dx because we are not yet derivating, right? We just rewriting the equation, really. So let's take a common factor of x on the numerator. We're going to get x squared plus 2x plus 1. Okay, you can already see what is happening here. You can already see what is happening. And then dx, we have the common factor of x, and now we factorize x squared plus 2x plus 1, of which we're going to get x plus 1 multiplied by x plus 1. Everything, here we have x plus 1. Everything divided by x plus 1. Okay, so obviously x plus 1 will cancel out with one of the x plus 1s. There we go. So dx is equals to, not equals to, what are we saying? So dx, in the numerator we have x multiplied by x plus 1. That's just what we have. And then when we multiply out, obviously we're gonna get x squared plus x. Now we can go ahead and derivate. This is equals to 2x plus 1. We're just using the power rule. Here we go. Right, most of the time I've never came across a situation like this where the numerator and the denominator don't cancel out to some extent. Okay, so I already expected that to happen before I could even attempt the problem. 7.2.3 y is equals to 3 up there x minus 1 over 3x. So we want to rewrite this in the following way. Y is equals to x to the 1 over 3 minus 1 divided by 3x. Okay, let's take that x from the numerator to the denominator. Y will be equals to x to the 1 over 3 minus 1 over 3 x to the minus 1. So when it was below, when it was on the denominator, it was x to the power 1. If we take it up to the numerator, we just need to change the sign from x to the power 1 to x to the minus 1. And then now we can then use the power rule, of which we're going to get dy dx. You see, now we're introducing dy dx because we actually want to do derivative at this point, of which we're going to have 1 over 3x. What is 1 over 3 divided minus 1? I think that is minus 2 over 3, but I don't want to take any chances. Minus 2 over 3 either way. And then plus 1 over 3, right? When we multiply minus a third by minus 1, and then to the power minus 2. This will be equals to, it's not always nice to leave our powers with a negative sign. So let's leave those positive. How do we do that? We take it to the denominator. So this will be x to the 2 over 3. The sign changes just like when we move up. And then plus 1 over 3 x to the 2. There we go. Question 7. Given f of x, that is equals to 2x multiplied by x squared minus 9x plus 24, 8.1, show that P, where the x coordinate is 3 and the y coordinate 36, is a point on the graph of f. 2 marks, quite surprising. So we're interested in P of coordinates 3 and 36. If it is a point on f, when we substitute 3, we are supposed to get 36. So 2 multiplied by 3, x is, we're trying to show that x is equals to 3 and y is 36 is a point on that function. So we substitute 3 in place of x, minus 9 multiplied by 3 plus 24. Right. So let me put that in my calculator. I have 6 multiplied by 9 minus 27 plus 24, and that is 36. So indeed, P is a point on this function. 2 marks. Let's take a look at 8.2. So 8.2, calculate the coordinates of the turning points of the graph of f. Okay, so turning points, we are thinking about gradient, the fact that it is equals to 0. So we need to derive this function. But let's multiply out with 2x so that we can use the power rule when we derive. F of x is equals to 2x to the 3 minus 18x squared plus 48x. So now we can go ahead and find f prime of x. Well, this is 6x squared minus 36x plus 48. And we need to let these be equals to 0 if we want to find the x coordinates of our turning points where the gradient is 0. So we can divide throughout by 6 to make our life more simple. So x squared minus 6x plus 8 should be equals to 0. Factors of 8, of which when we add, we get minus 6, x minus 4, x minus 2. So x is equals to 4 or x is equals to 2. These are the x coordinates of our turning points, but we're looking for the actual coordinates. So we then need to find the f of 4 here. And here we need f of 2. So f of 4 to 4 to the power 3 minus 8, x is 4. We square that plus 48, x is 4. Here I'm getting 32. And then what about f of 2? F of 2, we substitute in 2 throughout. So let me just replace 4 with 2 and see what we end up with. I'm getting 40 here in place of 2. So here we go. We have the coordinates of the turning points. Well, let's write them in coordinate form. 4 goes with 32 and 2 goes with 40. But we know from 8.1 that this is another idea. We are done with this question. I'm just thinking about something else. We know about from 8.1 that 3 goes with 36. I'm trying to see if this makes sense, right? 4 goes with 32. Oh, well, let's start here. 2 with 40, 3 with 36, 4 with 32. Okay, that's fine. That's fine. Yeah, if 3, which is between 2 and 4, was not following some sort of pattern, I would be skeptical about our answer here. So these are the answers here. These are the turning points, right? I don't know why this math is exciting me today, but let's just solve the problems. 8.3, draw a neat sketch graph of f, indicate the coordinates of any intercepts with the axis and of the turning points. Okay, so let's gather our information. TP 4, 32, 2, 40. Okay, let's find our y-intercept where we let x be equals to 0. So y-intercept will be equals to if we substitute 0 into this equation, everything cancels out and we just end up with y is equals to 0 here. So where we have the y, we actually have one x intercept because we have 0 and 0 here. So this is the coordinate 0 and 0. Okay, now let's find the x-intercepts. So the x-intercepts, we need to let y be equals to 0. So we're going to get 2x x squared minus 9x plus 24 being equals to 0. We already know that x is equals to 0 is one of the x-intercepts. Okay, but we then need to find the other two from this part here. X squared minus 9x plus 24 is equals to 0. Okay, so with x squared minus 9x plus 24, let me just use the quadratic formula and see what I end up with here. X is equals to plus 9 because we have minus 9 there, plus or minus the square root of, well, 9 squared minus 9 squared, that is 81 minus 4 AC minus 4 AC. A is 1, C is 24, so 24, everything divided by 2A divided by 2, so X is equals to, let me substitute that in my calculator. Well, 81 minus 4 minus 24. Issues are rising here. 81 minus 4 multiplied by 24. This gives me undefined. This gives me undefined. So I don't think we have any other intercepts here, because this gives me undefined, all right? We don't have any real rules there. So our x-intercept is just the y-intercept, which is at 0. So, okay, that is what we have there. That is what we have. So I think we're ready to sketch. We have the intercepts, we have the asymptote, well, not asymptote, we have the turning points. I think we are good to go. I think we can sketch here. So our axis, that is the y, this is the x. Okay, let's start with the intercepts. Right here at the origin, we have an intercept right here at the origin. So we are interested in the origin. We are interested here in the origin. And we also have the turning points 4 and 32. When x is equals to 4, we have a turning point of 32. And when x is equals to 2, we have a turning point of 40. When x is equals to 2. Okay, so let's find that. 2 goes with 40. So 2 and 40, they can be somewhere here. And then 4 goes with 32. So let's put it somewhere here. Okay. And then what else are we looking for? What else are we looking for? I think that is actually all. I think that is actually all. So we are expecting something like this. Let's see. That looks horrible. Let me just give that another try. Okay, this is another turning point, so we turn and then we go up. Okay, so so this is what we actually have here. This is what we actually have. What am I doing? This is what we actually have. Right, it kind of makes sense because we only have one x-intercept, so we don't expect the graph to go back and cut x once more. So that is what we end up with there. Okay, that is 8.3 neat sketch. Okay, maybe I should not put x there. I should put it here. Don't think it really matters, but it's fine. It's fine. You can deal with that. 8.4, determine the values of k for which the function being equals to k has 3 unequal roots. Okay, I see what is happening here. We have 2x x squared minus 9x plus 24 being equals to k. But we know that this is f of x. So f of x is equals to k. F of x minus k is equals to 0. So we need the values of k for which that is, that will have 3 unequal roots. 3 unequal roots. So k is shifting the graph some units down, right? But if k is positive, obviously it's gonna shift the graph some units up. So okay, what do we need? We need to know the y value at 2. The y value at 2 is 40. Okay, it will become apparent why we need that y value at 2. Now let me just trace this function. You're gonna see very soon why I'm doing that. So I retrace the function. Let me try and grab it and see if, okay, there. So at this point we have one, the question is saying we must look for 3 unequal roots. Okay, at this point we have one root at the origin. If we move down here, we only have one root, right? Because k can only move the function up and down. Okay, let's say we move up. We are always going to have one root if we keep moving up. So we need to move down in order to have a chance of having 3 roots. Okay, if we move down here, how many roots? We have only one. We only have one. If we move here, we only have one. But if we move to this point here, let's stay there at that point. If we move at that point, we have 2, right? But the second one also acts as an intercept. So k needs to at least move the what? Needs to at least move the y value at that turning point, at the minimum, to touch the x-axis. So k needs to be at least equal to the y value at 4. The y value at 4 is 32. K needs to be at least equal to 32. Okay, so in the scenario that we have in front of us, k is equals to 32. In that scenario, we have moved the function 32 units down. What about these? Okay, that would be 2. That will be 2 unequal roots. That would be 2. So we're not interested in that. We need k to actually be at least greater than 32, because at that point we have 2 unequal, right? 1 here and 1 here, but we need 3. So k needs to be at least greater than 32. Let me show you what happens then. Okay, so here k is greater than 32. We have moved the function more than 32 units down. Here greater than 32. Here greater than 32. And our condition is satisfied here. Take a look at this. We have this root 1, the second root, and the third root. So our condition is satisfied there. So when k is greater than 32, we're quite happy. We have achieved what we are looking for. But take a look at this. Let me just grab that function. When we move to this point, issues arise again. We are at a point where if the y value at 2 is touching the x-axis, we have 2 unequal roots. So issues are going to arise. If we have 2 unequal, we need 3. Okay, so we need k to be greater than 32, but we need k to be less than the y at x is equals to 2, which is 40. So let's write that in one statement. We are saying that we need k to be greater than 32, but k to be less than 40. In that way, we're gonna have 3 unequal roots. Okay, there we go. 8.5, determine the maximum value of f of x if x is an element of 0 to 5. Okay, so let's get rid of this now. We're interested in this portion 0 to 5. We are looking for the maximum value of x between 0 and 5, the maximum value. So we know that f of x, we also have f prime of x. We have determined it somewhere. Let me look for it. F prime of x, 6x squared minus 36x plus 48 minus 36x plus 48 plus 48. That is f prime of x. So we want the maximum. We can easily derivate this and equate it to 0, right? So take a look at this. 6x squared minus 36x plus 48 is equals to 0. What did we do last time? We divided by 6. We got x squared minus 6x plus 8 being equals to 0. And then we factorize factors of 8. Okay, x minus 4 multiplied by x minus 2. This gives us 0. So x is equals to 4 or x is equals to 2. Okay, so these are our values. X is equals to 4 or x is equals to 2. So which one gives us a greater y value between x is equals to 4 and x is equals to 2? At x is equals to 2, we have 40. At x is equals to 4, we have 32. So clearly here, we have to go with x is equals to 2 because we know that y here is 40 and y here is 32. So we go with x is equals to 2. The maximum value here, y is equals to 40. We are looking for the maximum value. I almost forgot the equation there. Show that the area of the figure is given by a is equals to 2 pi multiplied by r squared minus 200r plus 20,000. Okay, this is the kind of equations we expect in optimization, question 9. So let's take a look at what's happening here and show that a is indeed equals to that expression. A business enterprise has asked you to design an advertising disc that consists of 2 circles and has the same shape shown in the figure below. The larger circle has a radius r and the smaller circle head has a radius small letter r. The values of r, capital letter R and small letter r must vary, and capital letter R plus small letter r should give you 200 millimeters. To minimize cost, the enterprise also stated that the area of the shape must be a minimum. Okay, that is the information we have. What can we extract from that paragraph there? R plus R is equals to 200. That's what we can extract. And then 9.1, we're supposed to show that the area of the figure is given as this equation here. So let's take a look. We have the bigger circle and the smaller circle, right? So the area of the bigger circle will be pi r squared, and the area of the smaller circle will be pi r squared. But we need the area of the entire figure, so that is going to give us the area of the figure being equals to pi r squared plus pi r squared. Okay, that's somewhere to start. That's somewhere we can start. But take a look at this. In the equation we're given, we don't have any small letter r. We only have capital letter R. So it would be wise of us to write the small letter r in terms of the capital letter R, so that in our equation we don't have any small letter r. So making small letter r the subject of the formula, we get 200 minus capital letter R. So our area will be equals to pi r squared, the capital letter, plus pi, and then in place of the small letter r we substitute 200 minus capital letter R and we square that. Okay, so take a look at this. We have pi and a pi, so we can take that as a common factor. So the area will be equals to, there we go, we have pi as a common factor. Here we're going to be left with r squared plus 200 minus r squared. There we go. So the area will be equals to pi. R squared, that's just r squared. What about 200 minus r squared? So 200 multiplied by 200 will give us 40000. That is 40,000. We carry the zeros. Okay. And then 200 multiplied by minus r is minus 200r. You multiply that by 2, you get minus 400r plus minus r multiplied by minus r, that will be r squared. So take a look. The area will be equals to pi. R squared plus r squared will give us 2r squared. And then minus 400r plus 40,000. So we are at this point. Look at how it differs from our equation that we are supposed to prove. The only difference now is that here we have pi, and then on the equation that we are given, we actually have 2 pi. We actually have 2 pi. So how can we make sure that we have 2 pi? We can take out 2 as a common factor from those terms inside the brackets. If we do that, we're going to get the area being equals to 2 pi. We pull 2 out, and then we're going to be left with r squared because we have pulled the 2. Here we're going to be left with minus 200r because we have pulled the 2. And then here we're going to be left with plus 20,000. And this is exactly what we're supposed to show. So here we go. 9.1, let's take a look at 9.2. So 9.2 says that let's determine the values of capital letter R and small letter r if the area of the figure is a minimum. So the area is 2 pi r squared minus 200r plus 20,000. We want this to be a minimum. So obviously we're going to derivate and equate to 0. So when we multiply out with 2 pi, we get 2 pi r squared. We're moving backwards now essentially. Minus 400 pi r plus 40,000 pi. Okay, now we can derivate. Okay, when we derivate, we're gonna get 4 pi r minus 400 pi. This will give us 0 because we just have constants. And then this is what we need to then equate to 0 because we want our area to be a minimum. So let's pull out, well, let's just take this 400 pi to the right hand side. We don't have to take anything out as a common factor. Well, we can take 4 as a common factor, but it's okay. Let's just take 400 pi to the right hand side, of which it is going to be positive because it was negative. So, okay, r will be equals to 400 pi divided by 4 pi. Okay, pi and pi cancels out. 4 divided by 4 is 1. So r is equals to 100. So there we go. R is equals to 100. But we need to determine the values of capital letter R and small letter r. We have capital letter R. Let's find small letter r. Small letter r, we have said that it is equals to 200 minus capital letter R. So we're going to have 200 minus small letter or capital letter R, which is also 100. So this is 100. So take a look at this. Small letter r and capital letter R are equals to each other. They need to be equals to each other for the shape to be a minimum. Okay. 9.3. 9.3 says, hence explain why the shape suggested by the company is not possible if you want to maintain a minimum area. Okay, let's go back to the given information here. What are we missing? The values of capital letter R and small letter r must vary. That's what's required. But in order for this to be a minimum, the values of capital letter R and small letter r, they must not vary. They must not vary. They must all be equals to 100, right? So this shape is impossible because they are saying that they want it to be a minimum and they want the values of R and R to vary. But that cannot be true at the same time. Those two events are mutually exclusive. Here we go. Given that the probability of A is equals to 0.45 and that of B is equals to 0.25, determine the probability of A or B if A and B are mutually exclusive events. So the probability of A or B is equals to, generally, right, P of A plus P of B minus P of A and B. But if they are mutually exclusive, the probability of A and B is 0. They cannot occur at the same time. For instance, the probability that it will rain and the probability that it will not rain, those two things, those two events, they cannot occur at the same time, right? It cannot rain and not rain at the same time. So the probability of A or B, because they're mutually exclusive, will be equals to 0.45 plus 0.25 minus 0, B, which will give us 0.7. So that is the probability of A or B, given that they are mutually exclusive. 10.2, let's take a look at 10.2.1. A survey was conducted in one of the schools in our province with a population of 50 teachers. 30 of the educators indicated that they each own a car. 2 educators were randomly selected, one after the other, without repetition. So let's take a look at this. Oh, well, the first question, represent the given information on a tree diagram. Clearly indicate the possible outcomes of the event. Okay, so let's take a look at this, right? We are told that 30 of the 50 teachers say that they have cars. 30 of the 50 see that they have cars. Well, let me represent it in the following way. So 30 of the 50 see that they have cars. So how many don't have cars? So how many don't have cars? Should be 20 over 50, right? So let's say that one of the teacher, that is the first teacher to be selected randomly, has a car, right? The first teacher to be selected randomly has a car. So what is the probability that on the second selection, the teacher selected would also have a car? So there is no replacement here of any sort, right? So now we are left with 49 teachers because the first teacher with a car has been selected, right? And then how many teachers with cars left? 29, because there are 30 in total. And then let's take a look at the outcome of having a teacher with no car if the first teacher selected has a car. So teacher with cars, or with no cars, not with cars, with no cars, we still have 20 teachers with no cars because the first teacher that was selected is a teacher with a car. But our total of teachers now is 49 because we have removed one teacher. Okay, and then let's take a look at the other way. The first teacher selected does not have a car. What will be the probability that the next teacher selected has a car? So the teachers with cars is still 30, right? But the total is now 49. And then now the other outcome, teacher with no car. So the first teacher selected has a car. So of that 20, we are left with, the teacher selected does not have a car, right? Which is 20 teachers. And now that we want to select the second teacher, we are left with 19 that don't have cars. So that is 19 over 49 because there is no replacement. We are selecting one after the other without taking the teacher that we've selected first back into the selection pool. So this is our data represented in the form of a tree diagram. Okay. 10.2.2, find the probability that only one of the educators selected owns a car. Okay, so let's take a look at this outcome. This outcome here, let me change my color. This outcome here is car. Both teachers have a car there. And then the outcome here is car. One teacher has a car, the other one does not have. Here, the first teacher does not have a car, the second one has. And here, lastly, they both don't have cars. So 10.2.2, find the probability that only one of the educators selected owns a car. Only one. So let's take a look at this. We're interested in this outcome because in this outcome, only one teacher owns a car. We're also interested in this outcome because only one teacher owns a car in that outcome. So let's say that the probability of C and not C, the probability of having the first teacher own a car and the second not have, will be the probability of owning a car for the first teacher, which is 30 over 50, multiplied by the probability of the second teacher not having a car after the first has. That will be 20 over 49. And this is equals to, so let me just put it in my calculator. 30 over 50 multiplied by 20 over 49. That is 12 over 49. Okay, so I have 12 over 49. But this can happen in two ways, right? The first teacher selected may not have a car and the second teacher might have a car. So let's look at the probability of that outcome. The probability that the first teacher does not have a car is 20 over 50 multiplied by the probability of the second teacher having a car, which is 30 over 49. Okay, I think we should end up with the same thing here because on the numerator we have 30, 20. On the denominator, we have 40 and 49, which are also multiplying each other. So we're going to have 12 over 49 here. So the probability that that only one of the educators selected owns a car will be 12 over 49 plus 12 over 49. So let me put that in my calculator. I'm getting 0.49 if I run it off to two decimal places. So that is 10.2.2 Let's take a look at 10.2.3. Find the probability that the two educators selected each owns a car. So we want the probability that the two educators selected each own a car. So the probability of car. So this is what we're interested in, right? So the probability that the two teachers selected own a car will be 30 over 50. That's the first one. And then when we select the second one, we're left with 29 over 49. Okay, so 30 over 50 multiplied by 29 over 49. Let me just check if I had represented the data in the correct way. Yes, that is totally fine. Okay, when I put it in my calculator, 0.36. So 10.2.3, 0.36. Okay, I think we're done with that. 10.3, you require a password for an online account. The password must have 3 numerical values. So, well, let's make sense of that. 3 numerical values. So we need the numbers there. We need the numbers. Which numbers, we're not really sure about that, but we're going to figure it out. And then followed by 2 vowels. So we needed 2 vowels here. Vowels, obviously, A, E, I, O, U. How many possible passwords if repetitions are allowed? Okay, so numerical values, we have 0 to 9, which is 10, right? So we can have 10 here, one of the 10 numbers, one of the 10, one of the 10 vowels, one of the A, E, I, O, U, one of the 5, not 6. So 5 multiplied by 5. So this is just equals to 10 to the 3 multiplied by 5 to the 2. Whatever that is equals to, you're supposed to put that in your calculator and get some answer. Right. That is 10.3.1. Let's take a look at 10.3.2. Determine the number of possible passwords with the following conditions. So, okay, we still need those digits. We still need 5 digits. Yeah. Let's take a look. If repetitions are not allowed, the password does not start with a 0 and it ends with a vowel A. Okay, so this is the last position where we need to have A there. So how many A's do we have? We only have 1 A in our vowels. So it's only one possible vowel that can occupy that last spot. And then repetitions are not allowed. So here on the other spot that we need vowels, that we need to place a vowel, we are going to be left with 4 vowels because repetition is not allowed and A already occupies the last one. So we're going to have 4 possible vowels here. Okay. And then the password does not start with a 0. So if it does not start with a 0, it means that in this first position, we are not supposed to have 0. So of those 10 digits, we can only have 9 there on the first spot. Okay, so we have placed a digit on the first spot, which is 90. How many digits are we therefore left with? Well, we are left with 9. We are left with 9 digits here because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10, right? We cannot place 0 on the first spot. So we are only interested on these 9 digits, right? And then after we place one of those 9 digits on the first spot, let's say we place 7. We are still left with 9. So we have 9 multiplied by 9. And then ultimately multiply by 8 at the end, because any digit of the ones that are left can occupy that third spot. So there we go. You put that in your calculator and you get some answer. Those are the number of possible passwords with the given conditions. Here we go.